Hello there, our wonderful and beloved viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That channel is specially created for you and I to come together to tackle mathematics and demystify the age-long phobia often associated with this all-important subject, one topic at a time. I wish to appreciate you all sincerely for being with us on this station, for staying tuned and being our consistent subscribers and viewers. Please don't forget to like, share, subscribe, comment. Thanks and stay blessed. Now, in our previous video, we have looked at the concept of functions on function under the broad category of the topic differentiation or differential calculus. And there we explained that in function of functions, we are creating a new function or functions out of a given function, whereby we introduce a letter u, say, for example, to represent the content of the bracket. And by so doing, we are breaking the question down into steps, say from y to u and then u to x. And the approach to adopt in solving such is the chain rule, whereby we say that dy dx is simply dy du times du dx. That's pretty much a fantastic way of solving that aspect of the topic if you are writing an essay or theory type exam. However, in multiple choice exams, popularly called objectives, where you don't necessarily have to show an elaborate detail of how you got to answer, there should be a very quick way of getting the answer. And that is the essence of today's lesson. We are looking still at functions on functions, but multiple choice examination approach, where the examiner does not necessarily expect you to detail in elaborate fashion how to get your answer. What do? We simply say that in that case, dy dx equals internal differentiation multiplied by external differentiation. This is very key to really approach this aspect for a multiple choice examination. On the board, I have 4 questions carefully selected, cutting across the 4 areas of algebra, trigonometric, exponential, and logarithmic. So we see how it plays out for the various categories. Let's go without wasting time. Number 1, we have y equals to 4x squared plus 3x minus 1 to the power of 9. The content of the bracket here is 4x squared plus 3x minus 1. And by internal differentiation, it means we are going to isolate that, the content alone, and differentiate, neglecting the power as though it was not there. Then we multiply. On the other hand, we swap now by ignoring the content of the bracket and multiplying by the external differentiation. So let's have it. We have dy dx. So the content of the bracket now, to be differentiated, we simply differentiate this, and that gives us 8x plus 3. That's the content of the bracket, differentiated. Now multiplied by, let's now ignore the internal part and differentiate externally. So that gives us 9 bracket and what? 8. As though it's just a single letter. As if we have x to the power of 9, that would be 9x to the power of 8. So that's the name of external. So we have internal, we have external. So writing appropriately, we are going to have 9 bracket 8x plus 3. And we now replace the contents of the bracket. We fill it up by having originally 4x squared plus 3x minus 1. And in those 2 steps, we continue the differentiation for that function, which if solved by the elaborate method, we're going to get exactly the same answer. Isn't that fun? Let's look at question number 2 and see how the trigonometric aspect plays out. Now, for the question 2, we have y equals sine 3x squared plus 2x plus 9. This being the content of the bracket. So, for the internal differentiation, we're going to simply differentiate only this content alone. So dy dx question 2 goes thus. Internal 6x plus 2 multiplied by, now on the other hand, the external, we are differentiating sign, and that simply means cosine from our very first table. Cosine. So merging the two products, we have 6x plus 2 cos, we replace the content of the bracket originally, which is 3x squared plus 2x plus 9. And again, in 2 steps, that is the answer to the differentiation of y equals to sine all that. Okay, without wasting time, let's go straight to question number 3, which is the exponential. How does exponential play out? For exponential, the power is seen as the content of the bracket in this case. So we simply differentiate the y dx equals to, so the power 2x squared minus x plus 11. When we differentiate that, we're going to have internal, that's 4x minus 1, that's internal differentiation. The power is seen as internal because it's the one in the bracket. The external, when we differentiate exponential, we see end up having exponential. Remember from the very first table I gave. So we have here then 4x minus 1. Just replace the content of the bracket or the power, which is 2x squared minus x plus 11. And again, in 2 steps, we've gotten our answer. So if you're writing an exam that is multiple choice, at a certain level of proficiency, you don't even need to write anything down. Just look at the question and you click your answer. It's that simple. And lastly, we have the logarithmic aspect of it. So what is the rule for logarithmic? For logarithmic, the rule is such that you differentiate the content of the bracket is, in this case, sine. So differentiate sine, you're going to have cosine x divided by, do not exactly repeat the content of the bracket as denominator. That exactly is how logarithmic plays out. So I'm going to have here sine x. The log does not feature whatsoever again. So just differentiate the content, repeat that the content as denominator. And of course, from our knowledge of trigonometry, cosine over sine is cotangent. So we have cos x. It's that simple. And with that, we come to the end of the solution of function of functions using the multiple choice approach. And in summary, all you need to do is to do your internal differentiation and external differentiation and multiply. And for emphasis, the internal differentiation is done by differentiating the contents of the bracket given in the question, whereas the external is differentiating outwardly while ignoring the internal part, like vice versa. And I believe you found today's class quite interesting and fun. If you do, please don't forget to like, share, subscribe, and stay tuned when the next one is dropped. See you then.